Now, let's review gear pumps together. Gear pump selection is generally similar to other pump types. However, there are a few key differences. When you return to the main page, you must first select a fluid. In this case, you should select from high viscosity fluids, not from standard fluids. If you select a normal fluid instead, gear pump options will not be available. Therefore, you must select from high viscosity fluids only. When you choose any fluid from this section, its density and viscosity values will be filled automatically. If your desired fluid is not listed, you can select a similar fluid or enter the values manually. Next, enter the required flow rate and head values. Note that pole selection is not available for gear pumps. The system does not allow it. This is because gear pumps typically operate at lower speeds than standard motors. At the bottom, there are two model types: internal gear pumps and helical gear pumps. Helical gear pumps are labeled as ED, while internal gear pumps are labeled as EDPI. After selecting the model, click the green List Pumps button. A pump filtering table will appear. This table is different from other pump tables. It only displays maximum flow rate and pump model information. This is because the performance values are manually defined in gear pumps. Gear pumps are not automatically calculated like other pumps. The system filters pumps based on the flow rate you enter. For example, if you enter a flow rate of 10, only models such as EDP 1010 and higher will be listed. Lower capacity models like EDP 1006 or 1003 will not be displayed. Therefore, the most accurate approach is to enter a low flow value, such as 1, and list all available pumps that the listed values represent maximum capacities. For example, the EDPI-1 model has a maximum flow rate of 6, which is valid at 1450 RPM. If you enter a flow value of 4, this pump may not appear in the list. For this reason, it is recommended to enter a low value and then adjust parameters manually in the detail graphs. After selecting a pump, proceed to the detail page. The first screen displays the pump curves. There are 3 different curves in this section. The first curve shows the relation motor speed and flow rate. You can click on the curve and adjust the turquoise vertical line manually. As you change the speed, the flow rate changes accordingly, and vice versa. The second curve represents viscosity and speed. Here, you must define the viscosity of the fluid to be transferred. If you do not know the viscosity, you can go back to the main page, select a reference fluid from the high viscosity list, and obtain an approximate value. Then, based on this viscosity, you can manually adjust the motor speed using the turquoise line. After selecting the speed, you can easily observe the corresponding flow rate in the upper curve. The third and bottom curve represents pressure and motor power. In this section, define your pressure value, and the system will suggest a suitable motor power. In other pump types, these values are calculated automatically. However, for gear pumps, these parameters must be defined manually. Next to the graph section, the Dimensions tab displays pump drawings. In the Materials tab, you must assign materials to the pump. Do not use the impeller or stuffing box selections in this section, as they do not apply to gear pumps. Instead, use the gear icon for selection. In the top menu, next to Materials, you will find the Flanges and Motor tabs. In the Motor tab, you can manually enter motor specifications. Since speed is critical in gear pump selection, motor speed must be selected carefully. Next to the Motor tab, the Mechanical Seal section allows you to assign materials and model details. On the far right, you will find the Print section. All manually entered values will be compiled into a report. You can either print the documenter, save it as a PDF file,